Hello guys, welcome to the studies of calculus. Particularly today we are starting with the introduction to limit, that is unlocking the mystery of change in mathematics, a behavior or a journey into how things behave as they get closer and closer to something else. This topic will help us to understand how object behaves when they get closer to something else. Now, why do we need to learn limits? Now, in real life situations, sometimes we cannot calculate a value directly, but we can still predict what will happen by looking at the values that get closer and closer. It happens. But we also need to understand that limit also help us to answer the question, what is the value getting closer to if we can't calculate it directly? So here we need to understand that sometimes we cannot calculate something directly, but we can know the behavior of it to know how or what the value is getting closer to. Now, we have a real life examples that we need to use to understand this concept. The real life examples include approaching a red light when driving. Now, let's look at a car, that is example, as your school car approaching a red light. Your speed approaches 0. So now my question is, if you see a red traffic light and the car start to reduce its speed to get to the speed of 0, what is your prediction and what will be the behavior of the car? Automatically, when it is getting closer to 0, it means the car is coming at a stop. So here we need to understand that the behavior of the car when the speed is getting to the 0 means that the car will eventually stop or will come to a stop. Another real life example is bringing a thermometer near a boiling point. When the temperature gets closer and closer to 100 degrees Celsius, you start to know the behavior of the boiling water. You see marbles indicating that the water is about to start to boil. So here, that is an example, real life example of a limit. Starting to know the behavior of something when it is getting, the value is getting closer and closer to something else. So now, let's understand the intuitive meaning of limit. If y equal to f of x, then a limit describes what value. For me, I call it approximate value of y. And y indicates the function is getting closer to as the input x get closer to some numbers. So the limit of y means that what is the approximate value? What is the behavior of y when x is getting closer to some numbers where x is known as the input? That is, you input to get the image. That means what to be the approximate image when x is getting closer and closer to some numbers. So we may not be able to plug in the values directly, as maybe sometimes when you plug in the values directly, you might be having an undefined expression, but we can still observe or identify the behavior nearby. So it means that limit help us to predict the behavior near difficult points. Now imagine a man walking towards a door. Even if he never touches the door, he can get closer and closer to the door. So this is an example of a limit. So the man will be facing the door, getting closer and closer to the door. At the end of it all, the man will get to the door, which means that we know the behavior, but we have to understand that the behavior is as a result of the man getting closer and closer to the door. That is the intuitive meaning of a limit. Now let's see one example here. I have a magnifying lens to expand or magnify the points or values for me to know the behavior of this particular point. So here you can see that as the input, that is the x, getting closer and closer to 2, f of x is also getting closer to 5. So the behavior is such that when x get closer and closer to 2, the function f of x will also get closer to 5. So that is the understanding of limit. What happens when the input get closer and closer to some numbers? Good. Now let's get to know the formal meaning of a limit. For any function f of x, when we say the limit as x approaches a of f of x equal to L, what it means is that what is the behavior of f of x when x is getting closer and closer to a? So this expression that you see here means that as x get closer and closer to a, the value of f of x also get closer and closer to L, even if f of a may not exist. So all what we are saying is that L indicates the behavior of f of x when x approaches a. All these things that we are learning is about changes that occur between two quantities. So the key point which we need to understand is such that we are not concerned whether x actually reaches a. We only care about what happens as x approaches what? A. So whether it reaches or not, our concern is what happens when x moves closer and closer to A. And from this relation, it means that what happens when x moves closer and closer to A, then the result will be the f of A will be f of x will be equal to L. That means the behavior will be L. So here, a very simple example is here for us to understand this particular concept. What is the behavior of f of x equal to 2x plus 3 when x approaches or map to 4? So in this case, we can write this thing mathematically in the form limit as x get closer to 4. That means as x approaches 4 of 2x plus 3. We want to know the behavior of this particular function when x get closer and closer to 4. So here, let's look at this particular table. The x values here indicate all values that are closer to 4, 4.2, closer to 4. So when you substitute 4.2 as an input to the function f of x, the result is 11.4. When you substitute 4.1 as an input to the function, the result is 11.2. You do the same thing for 4.01, the results will be 11.02. When you substitute 3.9 to this particular function as an input, the result is 10.8 and so on. We have 10.98 for 3.99. 3.99910 will be 10.998. So which means that all these values indicate a closeness to 4. So these values is coming closer and closer to 4. And what is the behavior? The behavior is such that as x get closer and closer to 4, f of x also get closer and closer to its approximate number, which is 11. So here, what is the approximate number for 11.4? Is 11. The whole number for 11.2 is 11. The approximate number for 11.02 is 11. The approximate number for 10.8 is 11. 10.98, 11, 10.998 is 11, which means that as x gets closer and closer to 4, the approximate number or the behavior of f of x will be 11. So now look at this particular graph. Here the direction is indicating that x is getting closer to 4. So when x gets closer and closer to 4, the behavior of this particular function, when you use the magnifying lens to identify it, you are going to realize that the function will get closer and closer to 11. Good. So here, that is how it behaves. So the limit as s approaches 4 of 2x plus 3, what I need to do to find the behavior of this particular function is to substitute the x equal to 4 as an input to the function, and the result is 11, and which indicates the same behavior as the number getting closer and closer to 4 for the function f of x. So here, when x gets closer to 4, the behavior of this function is such that it also gets closer to 11. So look at the calculation that we have here. Now, approaching a point where function is undefined, let's consider this particular function g of x equal to x squared minus 2 divided by x plus 2. What happens when x gets closer to minus 2? Anytime you do a direct substitution, you are going to realize that your expression will fail as shown below. So when you substitute the minus 2 directly as we used to do in the first instance, you are going to realize that the results will be undefined, but we can still find the approximate by taking values closer to minus 2 as shown below. So look at this graph. We can still find the approximation when the x is approaching minus 2. So here we have values getting closer to minus 2. So minus 2.1 gave us this value as an input to the function g of x. Minus 2.01 gave us this value. Minus 2.001 produces this value. Minus 1.999 also resulted in minus 3.990. Minus 1.99 also resulted in minus 3.9900, which means that when x is getting closer and closer to minus 2, we are having these results as the behavior of g of x. So it means that anytime x gets closer and closer to minus 2, the behavior of g of x will be in this form. It is also going to be getting close and close to minus 4. So we have an example. We have the mathematical calculation of this particular function as this format. We have here, we just factorize the numerator, then we do cancel the denominator and the numerator to end up with the result as s minus 2. So when you substitute minus 2 here, it will be minus 2 minus 2. The result will be minus 4. It means that when s gets closer and closer to minus 2, our final result or the behavior of g of x will be minus 4. So now, limits help us to approximate difficult quantities. So finding the exact area in the circumference of a circle was historically challenging. So, but we can approximate the area by drawing polygons inside the circle. It is a simple activity that we need to perform to understand limits. So as we increase the number of sides, the polygon get closer and closer to circle. That is one application of limit. So the area of the inscribed polygon approaches the area of the circle. So as the number of sides increases, that is to infinity, then the area of the polygon becomes the same as the area of the circle. So where the AN represents the area of the polygon with number of sides, and the A represents the area of the circle. So look at this diagram. This is a polygon with 3 sides. When we increase it to how many sides? 1, 2, 3, 4, 5. We have the polygon getting closer to the circle. When we increase it to 8 sides, it is getting closer and closer to the circle. When we increase it to some number of sides, which is getting to infinity, we are going to realize that the polygon is getting closer and closer to be the same as a circle. So the behavior is such that as the number of sides get closer and closer and closer to infinity, that is become large, the polygon also get closer and closer to be the same as the circle, that is the area become the same as the area of the circle. Now let's understand the standard limits of a limit. So when you have a function being equal to constant, the limit as x get closer to a will be the same as the constant. So when you have a function of f of x equal to x power n and f of x equal to x, if I want to find the limit as s approaches a, the behavior of the function is such that anywhere I see x, I will substitute the a as my input, that is the approximate value or behavior of the function when s gets closer to a. So when you have f of x equal to x, then we have the limit as f of x equal to, we are going to just substitute the value of a as x. So we also have the same thing when you have the sum of function g of x plus h of x plus k of x. If we want to find the limit, it means that we just have to substitute x equal to a, that is a become the input for each respective function. So let's look at a very simple practical example. We are to find the limit of this particular function as x gets closer and closer to 3. So what is the behavior of this function? The behavior will be such that anywhere I see x, I will substitute 3 as my input, then I will just work it out, and the result will be 18 plus 5 equal to 23. The same thing happens to this side. We should evaluate this function, this addition of functions here as x gets closer and closer to minus 3. In doing that, the solution will be anywhere I see x, I want to find the approximate number for this particular function when x gets closer to minus 3. So x will be the minus 3 will be the input as x. So here we have minus 3 here and minus 3 here. Then we end up with here giving us 9, and this 1, 2, 3 times minus 5 give us minus 9. So 2 times 9 minus 9 plus 1, and we end up with 18 minus 9 plus 1, and the result is 10. So that is about the understanding of limit. So we have some common mistakes that students normally make when it comes to understanding limit. Substitute it directly even when division by 0, that is even when there is an undefined expression. So always check if direct substitution gives a valid value first before you continue to find the behavior or the limit of the function. So assuming limit always equals the function value, limit depends on approach behavior, not always actual value at that point. So we are interested in the approachable behavior of that particular function. So forgetting to simplify first, always you need to simplify the expression when you get to the point of an undefined expression before substituting your values to find your limit. The next one is confusing your left hand limit and the right hand limit. So what we need to understand is limit is being applied in differentiation, continuity, and integration. So we have the limit, differentiation, after that we go to continuity, after that we go to integration. So limit become the basis for the understanding of calculus. So we have a practice session here. Evaluate the following, that is, we have the I, and I, and send your result to this particular channel for us to go through it for you. Take care. Don't forget to follow or subscribe to this particular channel.